Okay, class, we've been talking about rectangular coordinates and polar coordinates, and a polar grid is going to look a little different here because we go through some angle and then from the pole we move out some number of units from where that angle terminates. And this is our pole and our polar axis. But over here we've got just the typical XY pair, and we've discussed how to turn these points into polar coordinates, or to take polar coordinates and turn them into rectangular coordinates. And we're going to do the same thing now with equations. Okay, so let's graph our first polar equation. It's going to be a simple equation where the only constraint here is that the radius from the pole is 3 units. So here we've got 3 units. Let's look at just our important key locations. So we like to label 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay, and this will be enough to give us the idea here. So the radius is from the pole is 3. So I get a key point here, and then I can see 3 units out here. And as I go to stay 3 units away, I'm basically creating a circle with a radius of 3. Okay, and so as you start to fill these in, you can see that just sweeps around here and creates this circle. All right, and remembering that the coordinates are r theta, so this is just saying, hey, we're going to lock the r part to 3 for no matter what angle you give me. So that's what we've got here. So that's going to form a circle of radius 3 for every possible theta angle from the polar axis all the way around. This also means that if I wanted to convert this equation to rectangular coordinates, then we know that r squared is equal to x squared plus y squared. So let's square both sides of this so we can substitute for r squared. So I'm going to now substitute for r squared, the x squared plus y squared equals 9. And this is your circle with the radius of 3. Okay, let's look at another equation in polar form. So this is just saying, hey, my angle is pi over 3, and that's wherever else I go along the polar axis, I'm going to take the angle to be pi over 3. So pi over 3 is going to be, I guess we should label these first. So this is pi over 4, pi over 2, 0. So I'll kind of leave it there. Okay, so we've got pi over 3 sitting right here. And if I move anywhere along the polar axis, from there I want to go an angle of pi over 3. So that's going to create the terminal angle that reaches out to our pi over 3 everywhere I go. Now if I go backwards on the polar axis, remember the pole is what we rotate around or revolve around. So if I go back here, I need to do an angle, and again it's counterclockwise. So if I do a counterclockwise pi over 3, then that's going to take me down here. Okay, so everywhere I land as a point on the polar axis, I'm going to be displaced to the angle pi over 3. So that's going to create this straight line runs through the pole. And it looks like that. Okay, and then to convert this to rectangular coordinates, we have to provide everything in terms of x and y. So which trig function involves both x and y? That would be the tangent, right? The tangent of theta is equal to y over x, which involves x and y. And then if we take the tangent on both sides, then I can substitute the left-hand side with y over x, and this is equal to a tangent of pi over 3, which we can just go get that off of our unit wheel, or if we've got it memorized by now, that means that y over x is going to be equal to the square root of 3 over 2 divided by 1/2. Okay, so y over x is equal to the square root of 3. And if I solve this for y, I'm multiplying both sides by x. I get y is equal to the square root of 3 times x. So this is just a line through the origin. The y-intercept is 0, and the slope of our line is the square root of 3. And so that just means if I go up by the square root of 3 and over by 1, I stay on the line.